Here's a challenging yet fascinating geometry problem that's sure to get your brain working. A semicircle is inscribed in a quarter circle. What fraction of the quarter circle is shaded in red? Give this problem a serious effort before watching the solution. Can you figure it out? So, how can we solve this problem? Let's set up an equation for the fraction that is shaded. That will be equal to the area of the semicircle divided by the area of the quarter circle. Now, let's define some variables. Let x be the radius of the quarter circle, and I be the radius of the semicircle. Now, the area of the semicircle will be equal to 0.5 times pi times I squared. And the area of the quarter circle will be equal to 0.25 times pi times x squared. Simplifying this, we get 2 times the squared over x squared. So, we want the relationship between the values I squared and x squared. How can we solve for a relationship between x and y? One way is to connect important points of line segments. In the semicircle, draw radii to the points of tangency to the quarter circle. This forms a right angle, and the line segments have a value equal to the radius of the semicircle, which is I. Notice how connecting the important points helps us uncover the hidden relationships in the geometry. We can also draw another line segment, which will also be tangent and have the value of I. Since the quarter circle is 90 degrees, this will also form a right angle. Therefore, in this quadrilateral, all the angles are right angles, which means it is a square. So all sides are equal to y. By using the Pythagorean theorem, the diagonal of this square is equal to y times the square root of 2. It's like solving a puzzle, step by step, seeing how the pieces fit together. Let's continue connecting more interesting points in this diagram. Draw the radius of the quarter circle through the center of the semicircle. Each of these will be equal to y because each of these is the radius of the semicircle. Therefore, the radius of the quarter circle bisects the chord of the quarter circle, and they meet at a right angle. Now, draw another radius of the quarter circle. Since it is a radius of the quarter circle, its value is equal to x. Now we have a right triangle here, and we can use the Pythagorean theorem. So we have I times the square root of 2 squared plus I squared equals x squared. Simplifying this, we get 3 times I squared equals x squared. That's the relationship we need to solve this problem. Substituting the value of x squared into our original expression, we get the value of the required fractional area, which equals 2 times I squared, over 3 times I squared, which is equal to 2/3. And that's our final answer. And there you have it. Thanks for watching. I hope you enjoyed the video. Hit the subscribe button for more interesting videos. See you in the next one. If you enjoyed this problem, you're going to love the next one we have in store.